What's up guys, welcome back to a brand new academic learning video, and in this academic learning video we are going to be covering more exponent properties. Now I know I haven't uploaded in a while, but I'm going to try to upload every week now. Okay, so let's get started. So now first of all, we talked about two properties in the last video, just a review. If we have A times B, and then we multiply that by A times C, we have A to the B plus C. Again, this is just a review, this is just from last video. So if we have like 2 cubed times 2 squared, that's equal to 2 to the 3 plus 2, or 2 to the 5th. All right, now the other thing that we covered, or the other main thing, is that if we have A to the B divided by A to the C, we have A to the B minus C. See, one is plus, one is minus, and one reason that one is plus and the other is minus is that from the last video, or let's just rewrite this. So A to the B divided by A to the C, I just split it up into two parts. Now from the last video, we learned that if we have 1 divided by a exponent, then that's equal to the negative of that exponent. So if we have A to the minus C, from last video we learned that that's 1 divided by A to the C. So now we see that these two, they're the same. So we can just plug this into that equation. So we have A to the B times A to the minus C. And now we have this rule. So we can just add the two terms. And in this case, it's B minus C. So that's just another proof that I didn't cover in the last video. But hopefully now you guys are reviewed. So let's move on to the actual topic. All right. Now, let's say we have something like A to the B to the C power. Okay, so let's just break this down real quick. A to the B to the C, so that can be written as like 3 times 2 to the 4th. So we have a product, and we're raising that to an exponent. So let's call this product to an exponent. Okay. Now, there's actually one way to simplify this. And let's just, to see how we can simplify this, let's just use an example here, like 3 times 2 to the 4th. So this is what? 3 times 2, and then we're multiplying that by 3 times 2, times 3 times 2, times 3 times 2. Okay, so we're taking this base, 3 times 2, and then we're multiplying it by itself 4 times. So that's what an exponent is. And now, one thing you might notice is that we have 4 3's and 4 2's. So this is equal to 3 to the 4th, because there's 3 multiplied by each other 4 times. Or, actually, let me rewrite this first. This is equal to 3 times 3 times 3 times 3 times 2 times 2 times 2 times 2. So there's 4 3's, and then there's 4 2's. So it's 3 to the 4th times 2 to the 4th. Now, one way you can see this is by taking this 4, and this 4 is going to be put here and put here. So let's just make that a bit more general, because that was just an example, not a proof. So if we have A to the C times B to the C, well, you can agree that this is AB times AB times AB C times. I'm just going to write this C times. Okay, now if this is C times, then we can rewrite this as A. There's going to be CA's, there's going to be CA's, and then there's also going to be CB's. CB's. Now, it might be a bit confusing on the letters, but stick with me here. So if we have CA's, that's going to be A times A times A times A times A, C times, and then it's CB's. So that's also going to be B times B times B times B times B, and that's also going to be C times. So if we're multiplying something by itself C times, that's A to the C, and same thing for B, that's B to the C. So that you might have gotten a bit lost in all the letters, but let's just break this down. A to the B to the C, And what we're basically just doing is multiplying it all together c times, and then in each of those c terms, there's going to be an a. So there's going to be c a's in total, and we can do the same thing with b. In each of the c terms, there's going to be a b. So we have c b's in total, and then from here we just use the definition of an exponent to simplify this down. Okay, so that is the product to the exponent rule. Let's use this in an example to see how this is useful. Let's say we have 2, and then we have x squared to the second power. Now, from our previous example, we know that this is, well, we put the 2, so the first term gets raised to the second power, and we multiply it by the second term raised to the second power. So this simplifies to 4 times, wait a minute, how do we do x squared squared? Well, this brings us to our second rule. If we have something like x squared squared, how can we write this? Well, I'm going to call this actually maybe exponent to an exponent. Okay, now you might recognize a pattern in these exponent rules, and that is I'm always proving them by using an example. Because exponents are actually kind of intuitive. The proofs aren't that hard once you get used to them, as long as you start with an example to make it make more sense. So let's say we have 2 squared to the third power. Okay, now what is this? So we're taking 2 squared and then we're multiplying it 3 times. So 2 squared times 2 squared times 2 squared. Now from here, we can use the previous rule from last video. If we have exponents that are being multiplied together, then we add the exponents here. So we have 2, and there's 3 2's, that makes 6. So 2 squared to the third power is 6. Now you might recognize that 2 times 3 is also 6. Let's see if we can establish a connection between multiplying the 2 exponents and the actual answer. Okay, so let's just move on to a bit more general. This isn't completely generalized because they're still constant terms, but this is just a bit more general. X squared squared. This is, well, x squared times x squared, 2x squareds. And now we just add the exponents. So this is x to the fourth. So again, we're multiplying these two things here. Now let's see if we can find a correlation between multiplying this and doing this by generalizing completely. Let's say we have x to the y to the z. So this is xy times xy times xy times xy, and we're multiplying together z times. So if we're multiplying x to the y together z times, we can use the addition rule where if we have the same bases, we can add the exponents. So let's see. The base is just x, but what's the sum of y z times? Well, that's just multiplication. If we have 2 plus 2 plus 2, and we're adding 2 together 3 times, that's equal to 2 times 3. So that's the same thing here. If we're adding y plus y z times, then that's just z times y. So now we've seen a generalization. If we have x to the y to the z, we can rewrite that out as x to the y being multiplied z times. And then when we add all of these together, it's x to the y z, or x to the zy. So if we have something like x cubed to the fourth, that's x to the third power times 4, so that's x to the 12th. Okay. Now, before we end off the video, I want to talk about one more rule. And that is similar to the previous one, but instead it's division. So if we have x to the y times, or divided by x to the z, then how can, or sorry, that's not what I meant. I meant if we have x divided by y to the z power, then how can we write that out? So that's similar to one of our previous examples, which was a to the b to the c power. So instead of taking a product to an exponent, we're taking a quotient to an exponent. Exponent. Okay, so this is just, well, if we have x divided by y multiplied together z times, that's x over y times x over y times x over y times x over y. I'm just going to skip straight here to the generalization because you're probably getting bored of exponents and want to move on. So this is x to the y being, or x divided by y being multiplied together z times. So let's see, this is, we have, if we just use our fraction rules, x times x times x times x, z times, or that's just the definition of an exponent, that's x to the z. And same thing for y times y times y times y, z times is y to the z. So if x divided by y to the zth power, that's x to the z over y to the z. So if we have like x squared divided by x, or sorry, I keep getting mixed up on my exponent rules. If we have x to the, or if we have 2 cubed squared, well, that's 2 to the second power over 3 to the second power. Okay, now one thing that people often forget, including me, is that the exponent rules go in both directions. So if we have a times b to the c power from our previous example, that's a to the c times b to the c. This goes in the other direction here. If we have like 2 cubed times 3 to the fourth, well, that's a, or sorry, not 3 to the fourth, 3 cubed. That's a to some exponent times b to that same exponent. So this follows our pattern here. So we can go in the reverse direction and make this 2 times 3 cubed. So we're taking this pattern, this maps to this. So then we just follow that pattern and made it go to this form here. So all of our rules can go in the reverse direction, and I encourage you to try out the reverse direction of some of these rules because they may be very useful. Exponent rules are probably one of the most useful things in math. So yeah, I hope you had a good time watching this video. And as always, if you had any questions, please comment them or email me or do any of that. And I will see you in the next video, which is going to be on radicals.